Industrial facilities depend on pumps to keep fluids flowing through piping. One basic type of pump is called a positive displacement pump. There are many different kinds of positive displacement pumps, and they move fluid in different ways. To keep the positive displacement pumps in your facility working properly, you need to have a basic understanding of how they operate and how to perform maintenance on them. A reciprocating positive displacement pump uses the back and forth or reciprocating movement of components such as pistons, plungers, or diaphragms to move fluid. One common type of reciprocating pump is the piston pump, represented here. Its main components are a cylinder, which is located inside a casing, a piston, a connecting rod, and two valves, a discharge valve and a suction valve. The connecting rod connects the piston to devices that move the piston back and forth. When the piston moves back on the suction stroke, it reduces the pressure inside the cylinder. The reduced pressure closes the discharge valve, opens the suction valve, and draws fluid into the cylinder. When the piston moves forward on the discharge stroke, it exerts a force on the fluid that increases its pressure. The increased pressure closes the suction valve, opens the discharge valve, and pushes the fluid out of the pump. At the end of the second stroke, the piston is in its initial position, and the cycle begins again. Basically, the piston draws fluid into the cylinder and then positively displaces it. In other words, the piston takes the place of the fluid. The pressure of the piston pressing against the fluid gives the fluid the pressure it needs to move through the discharge piping. The plunger pump and the piston pump that we've looked at are both simplex pumps. They're simplex pumps because they each have only one piston or plunger. A simplex pump has a limited capacity. These pumps are single-acting pumps as well. That's because fluid is admitted on one part of the reciprocating movement and discharged on the other part. This creates a very uneven pumping action, and the fluid is discharged in spurts. One way to help even out the pumping action associated with a single-acting pump is to use a double-acting pump. Double-acting pumps are designed so that each part of the reciprocating movement acts to both draw fluid into the pump and force fluid out of the pump. Here's an illustration of a simplex double-acting piston pump. It has a cylinder that contains a single piston, a discharge manifold that contains two discharge valves, and a suction manifold that contains two suction valves. When the piston moves to the left, the increased pressure on the left side closes the suction valve and opens the discharge valve on that side. At the same time, the reduced pressure on the right side closes the discharge valve and opens the suction valve on the right side. On the next stroke, the piston moves to the right, reducing the pressure on the left side of the piston and increasing the pressure on the right side. This closes the discharge valve and opens the suction valve on the left side, and opens the discharge valve and closes the suction valve on the right side. So during each stroke of a double-acting pump, fluid is forced out. The result is a smoother, more continuous discharge than you get from a single-acting pump. To overcome the capacity limitation of a pump that has a single piston or a single plunger, some pumps have two pistons or two plungers. These pumps are called duplex pumps. This duplex pump has two pistons that alternate their movements. It operates like two single-piston or simplex pumps that are side by side. Each portion of a duplex pump can be double-acting, as in this example, or single-acting. In either case, the strokes are mechanically timed to provide the smoothest possible discharge.